Okay, we're going to start chapter 6 now. Okay, we're going to talk about gases and pressure and properties of gases. So we're talking about the kinetic molecular theory of gases. So, right there in the name, kinetic. So we're talking about what? Energy of motion. So, according to the kinetic molecular theory, a gas consists of particles, atoms, or molecules that move randomly and rapidly. So the size of gas particles is small compared to the space between the particles. Gases are mostly empty space. Gas particles exert no attractive forces on each other because they're far apart. The kinetic energy of gas particles increases with increasing temperature. So the hotter they get, the faster they move. Just like you're walking and someone comes up behind you with a blowtorch, puts it on your butt, you're going to move a lot faster. When gas particles collide with each other, they rebound and travel in new directions. So think of like a pool table. When you break the balls and they go scattering all over the table, they hit each other, they bounce off, they go in different directions. When gas particles collide with the walls of the container, they exert a pressure. Now what is pressure? Pressure is force exerted per unit area. So it's force divided by area. The most common pressure you know is like if you have your tires, pounds per square inch, PSI. In science or in chemistry, we don't use PSI. We use something called an atmosphere. At sea level, the pressure is 1 atmosphere. 1 atmosphere is equal to 760 millimeters of mercury, which is equal to 760 torr, which is named after Torricelli, who invented the barometer. 1 atmosphere is 14.7 pounds per square inch, so if you're standing on the beach in Wilmington right at sea level, the air is pushing on you with a force of 14.7 pounds per square inch. And the bottom one, 101,325 pascals. We're not going to use pascals. You may have heard the term millimeters of mercury if you watch weather reports. Let's say the pressure is so many millimeters. When pressure goes down, you hear the barometer is falling. That's associated with bad weather. Low pressure systems are usually rain. High pressure systems, like we're having now, are associated with good weather. When the barometer is going up, that means good weather is coming. Sunshine, happy faces. If it falls real fast, that is storms coming. If it falls real fast, that is duck and cover. We're talking about tornadoes, hurricanes. Something like that. Okay? So if you listen to the weather report, you may hear about millimeters of mercury. We're going to cover roughly 6 gas laws. First one is Boyle's law. Boyle's law says for a fixed amount of gas at constant temperature, the pressure and volume of gas are inversely related. What does that mean? If we have a cylinder with a piston in it, and we have a certain pressure, I'll call that P1, and a certain volume, V1. If I increase the pressure on the piston, what am I going to do? Yeah, I increase the pressure on the piston. I'm going to push the piston down. Decreases the volume. So as one goes up, the other one goes down. That's what inversely related means. Now the pressure times volume is equal to a constant. So that means this times this is a constant. This times this is a constant. So therefore, this times this has got to equal this times this. To summarize Boyle's law, we could say P1 V1 is equal to P2 V2. So you notice here in this diagram, probably right on this, we have a pressure of 1 atmosphere, a volume of 2 liters. If we increase the pressure to 2 atmosphere, the volume goes down to 1 liter. So P1 V1 is 1 times 2, which is 2. P2 V2 is 2 times 1, which is 2. Okay? So that's Boyle's law in a nutshell. P1 V1 is equal to P2 V2. Nothing you don't conceptually know. You compress a gas, the pressure inside the container gets higher as the volume decreases. So in this example, we have a 4-liter container of helium, has a pressure of 10 atmospheres. What pressure does the gas exert if the volume is increased to 6 liters? So the key to doing these problems is, once again, pulling out the information. What is the initial pressure? 10 atmospheres. What's the initial volume? 4 liters. What's the final volume? 6 liters. What are we looking for is the second pressure. So setting up the equation and solving for P2, P2 is equal to P1 V1 divided by V2. So we have all of these quantities. So it's 10 times 4 divided by 6. The answer is 6.7. Now, the only thing you have to be careful for, again, is units. Remember I said units are important. Make sure your volume are the same units. They could be liters, they could be milliliters, whatever. Just make sure they're the same units. If they're not, you got to convert one to the other to get them the same. Same thing about pressure. Let's look at Boyle's law in relation to something that we all know how to do, breathe. When you inhale, the rib cage expands, the diaphragm lowers. That increases the volume of your lungs. So when the volume increases, what happens to the pressure? They're inversely related. So as the volume goes up, pressure goes down. So now the pressure inside your lungs is less than the pressure outside your lungs in the air. So what does the air outside do? Rushes in. We call that inhaling. Exhale, the rib cage contracts, the diaphragm is raised, the volume inside your lungs gets smaller. As the volume inside gets smaller, the pressure goes up. So now the pressure in your lungs exceeds the outside pressure. So the air in your lungs does what? Goes out. It's called exhaling. Actually, it's carbon dioxide most of it comes out. The gas inside your lungs comes out. So, there you go. There's the scientific explanation of inhaling and exhaling. According to what?
You didn't realize they called expire and they were inspired in the terminal.
Could be. Could be. I prefer inhale and exhaling. I really don't want to expire.
Well, that's what they call it too, inspire and expire.
So, Charles's law tells me how the volume and temperature of a gas are related. Okay, without even looking at the board, you have a balloon with air inside. You heat the air inside the balloon. What's going to happen? It's going to expand. So, as the temperature goes up, the volume goes up. So it's a direct relationship. So we can say the initial volume and the initial temperature is equal to the final volume divided by the final temperature. V1 over T1 is equal to V2 over T2. That's a direct relationship. So that's Charles's law. That's the second one. Okay. I'm going to go off a little bit of tangent here, see if you can figure this out. You have a balloon with a fixed quantity of air in it, so a fixed mass of air. You heat that air, what does the balloon do? It expands, so the volume gets bigger. So, what about the density of that air inside the balloon? Is it equal to, greater to, or less than the air outside the balloon?
It's greater.
What is density? Give me the formula for density. Density is equal to mass divided by volume. So we kept the mass constant, right? We've increased the volume. So what happens to the density? This number gets bigger, the density goes down. So the density inside the balloon, the air inside the balloon, is less than the density of the air outside the balloon. So what happens to the balloon? No. Well, assuming that we strong enough to not fall. Well, it gets bigger, but what else does it do? It rises.
Heat rises.
So we call that a They have it in New Mexico every year, big celebration. Hot air balloons. That's why a hot air balloon rises.
So you're saying when it heats up, the balloon gets bigger, but it's the same amount of air, of course.
Yeah, so it's less dense.
Like, is it bombarding go crazy inside, it expands it? Okay.
That's not what I believe festival is in New Mexico. Is it Albuquerque or is it Mexico?
I said New Mexico.
I think it's in Mexico.
No. So,
I didn't hear you. Let's do that.
so we already said that heating things makes it
Okay.
expand. So therefore,
Density.
I'm not fat, I'm just hot.
That's a good one, try that.
Okay.
Yeah, like I say,
So if the temperature of a cylinder is doubled, the volume of the gas doubles. Notice temperature. Here's a key point. Right? People are going to take a test. Temperature is in Kelvin. So if the problem gives you temperature in Celsius, you have to convert it to Kelvin. Otherwise, you get the wrong answer. So, we also said hot air does what? Rises. So you have hot air. Hot air rises. Does that mean heaven is hotter than hell? No. Okay.
I don't know.
Philosophical question. So you have hot air mass comes along, meets a cold air mass. So the hot air does what? Well, the hot air is up. Thank you. I thought you were applauding. The hot air is up here. Cold air is down here. So it collides. The hot air starts cooling. So it then starts dropping. And what do we call that?
Wind.
Wind. Thank you. So we can get wind either by cool air heating up or hot air cooling down. So a lot of times when you see the weather people come in and they say, cold front is moving in, you can always tell when it changes if you're outside, because all of a sudden for about half hour or so, the wind will pick up. And that's all that hot air cooling off or cool and go. And then you can feel that temperature change.
Okay, and that correlation, how come it's windy during the day, but the wind settles down at night in most cases?
Because you don't have that air heating up, radiating from the ground. You have cool air, so you have cool air like right now. The sun comes out, starts heating up the ground, like here. It heats the air at the bottom. It's radiating off the ground. So now you got hot air here and you have cool air here. What's the hot air going to do?
Rise up.
So when it rises up, that also creates wind. So you get wind going,
Either way.
depending on what front is moving in.
I think that's why it's at the ocean, it's always really like windy more at the beach and stuff, because of the
Yes.
hot air with the ocean and all that.
Yes. Then, plus there's nothing to block it
Yeah.
when it comes in. How pressure and temperature of a gas are related. Gay-Lussac's law. All right, we're not even looking at the board. I have gas in a container, and I heat it. What's going to happen to the pressure? It's a fixed volume. It's in a container. Say this is a sealed container with gas.
Right? Okay.
I heat it. What's going to happen to the pressure inside?
Tight.
It gets greater. All right? And if you don't think that's happened, when you leave today to go home, before you get in your car, open the hood, unscrew the radiator cap, and look at the nice little green fluid in there. Put the radiator caper back on. Drive home as fast as you can. As soon as you get home, jump out, open up the hood, and open up the radiator cap. Why not?
You're gonna get burned.
Why?
It's the pressure.
Compressed.
Yeah, the pressure, because the gas in the liquid heat it up.
And you're gonna get lifer.
So, Gay-Lussac's law P1 T1 is equal to P2 T2. P1 over T1 is equal to P2 over T2. Which is why they tell you never throw an aerosol can into a fireplace or a fire. Or any kind of sealed can with a gas in there, because eventually you'll get hot enough to explode.
Wow.
I had a friend that did that one time. He put a canned bean, think of baked beans, in a grill and closed the lid, and he forgot to pierce the beans, and he was heating up the can, and the pressure, it exploded, and it blew the lid of the grill in the air, and the can of beans disintegrated in tiny little pieces. You couldn't even tell it was a...
Yes,
He created a bomb.
he created a bomb. Basically, that's what a bomb is.
Yeah. So, like, anybody would have been around that grill when it happened, they would have got majorly hurt.
Yes.
Like they throw the rocks on,
Sounded
you know,
bad.
campfire.
Or,
Moisture in the, rock.
if you're nasty and you take a pressure cooker, fill it up with nuts and bolts, different pieces of metal, put a little bit of water in there, seal the top on it, turn it on so it heats up, place it somewhere, like at the Boston Marathon. When the pressure exceeds the ability of the pressure cooker to hold it, the whole thing explodes, and all those little pieces of metal get thrown about, and you've created a major weapon of mass destruction. That's what he did. It's not very hard to do. So, and again, you've seen videos of people that do the thing with the Pepsi bottle and the works and aluminum foil. Generates hydrogen gas. You seal the bottle, and you throw it out there. Eventually, the bottle explodes. The hydrogen gas is flammable, so you get a nice little. Don't do that. That's a weapon of mass destruction. If they catch you doing it, they'll spend time at a federal correctional facility.
I knew somebody who did that, and they were just doing it as kids and throwing it and letting it explode, and then they went, but they didn't get one that didn't explode, so they went over there to check to see why it didn't explode, and by the time they got over there, they got scars all over their body.
It exploded on them.
Yeah, because it wasn't going off like the other ones were. For some reason, it got delayed.
Yeah, that's the
By
trouble.
time they ran out there and
They
checked
were
on it.
chemists, they didn't balance it out.
That's it. Balance it out right.
Yeah, they ran out there and was like, why isn't it exploding?
So when you talk about people making explosive material, it's not hard. You can do it with vinegar and baking soda.
What happened to Aquaman church?
They made little volcanoes. It's not
So don't go home today and say, our chemistry teacher told us how to make a bomb. Okay. I don't want Homeland Security paying me a call. If you call Homeland Security, just send them to my boss.
Yeah.
And the hell I'll down. Okay? I shouldn't be recording that. Okay. So increasing the temperature increases in the kinetic energy. So the molecules are moving faster. And we said molecules hitting containers cause pressure. So here's pressure. If I heat the molecules and they're going faster, pressure's going up. We can combine all of these, and it's called the combined gas law. P1V1 over T1 is equal to P2 V2 over T2. You see, if we hold the temperature constant, I have Boyle's law, the top equation. If I hold the pressures constant, I have Charles's law. If I hold the volumes constants, I have Gay-Lussac's law. So basically, instead of memorizing all 1, 2, 3, 4, memorizing, putting it on a sheet of paper, if you know this one, this is the only one you need. Because if the temperature stays constant, you're going to put the same number in for temperature, and they're going to cancel each other out. If the volume stays constant, you're going to put the same number in for V1 and V2. They'll cancel out. If the pressure is constant, you put the same number in. So that's good if you're going to change 2 out of the 3 factors. So there they are, summarized. Boyle's law, Charles' law, Gay-Lussac's law, combined gas law. So all these laws basically explain stuff you already know about. One that they didn't talk about there was Avogadro's law, which basically states, I'm going to put it down there, the volume is directly proportional to the number of moles. That's Avogadro's law. What does that mean? Okay, you have a balloon with a certain amount of air, certain amount of air in it. I add more air by blowing into the balloon. What's going to happen to the volume of the balloon? It increases. That's all that says. The more material you put in, the bigger the volume. Okay?
Yeah.
Who knows we can make blowing up a balloon so difficult?
I just thought baking cookies were easy. So.
It is easy. Baking cookies are easy.
I thought it was easy.
Is it that, Avogadro's law, is that N1 and N?
N1 and N2. V1, V2, N1, N2. Two. Where N is the number of moles. So, the more material I put in, the bigger the volume gets. Assuming I keep the temperature and pressure constant. Questions?
Assuming you do what?
Keeping the pressure and temperature constant. So if you blow up a balloon, I'm in a room, I blow up the balloon, I'm not changing the temperature of the room. And I'm not changing the external pressure. So when I add more air to the balloon blows up. So now, if I'm going to grill, so I have my propane cylinder here. Okay. I start adding gas to it. The cylinder doesn't get bigger, right? So I'm putting more gas in. So I'm putting more molecules in there, right? So pressure is determined by the molecules hitting the side of the container. So now I have more molecules hitting inside the container. What's going to happen to the pressure? It goes up. So when you do compressed gas, the cylinder, you keep adding more and more, the pressure builds up. And you seal it off. And usually they have a little protective thing on there. If the pressure gets too high, that little disc blows rather than the tank blows. Because if the tank blows, ouch. Big problem with hot water heaters.
Water heaters.
You know, you have that relief valve that comes off. If that relief valve sticks and the pressure builds up, and they've actually done it at Mythbusters, it'll launch that hot water heater up through your house, right through the roof.
If you can generate that much pressure, the heat.
Right through the roof. Roof? The ceiling, top of the house. You making fun of my accent? If you're from the South, you have no right to make fun of my accent.
Thank you. Yeah, they're really and they have the water heater turned high. Yeah, sure.
It will blow, and if it blows the bottom off, it acts just like a rocket. Same thing if you have a compressed gas cylinder, you know, those big tall ones with the...
Right.
If it falls over and you knock that neck off, you have a torpedo.
Oh, you know, you see on the action film, people hit the hammer and it's...
It will actually do that. There's cases where they... That's why the law is, if you have one of those, you got to have chained to something. Because if it falls over, and I've seen it happen,
knock the head off.
knocks the head off, it'll go right through a brick wall.
I was at home working on a house. I had my gas tubes, my nail guns, and when they're empty, they're still it's an empty tube, and they're sealed. I'll stick them in a fire and put wood around it, and hang it like a cannon, and shoot about 300 yards. I hit the chicken.
All right. I'm gonna stop there because you guys are getting way too